Advanced Mobile Phone System is an analog mobile cell phone system standard developed by Bell Labs, and officially introduced in the Americas on October 13, 1983, Israel in 1986, Australia in 1987, and Pakistan in 1990. It was the primary analog mobile phone system in North America through the 1980s and into the 2000s. As of February 18, 2008, carriers in the United States were no longer required to support AMPS, and companies such as AT&T and Verizon have discontinued this service permanently. AMPS was discontinued in Australia in September 2000 and in Pakistan by October 2004. History. The first cellular network efforts began at Bell Labs and with research conducted at Motorola. In 1960, John F. Mitchell, an electrical engineer who had graduated from the Illinois Institute of Technology, became Motorola's chief engineer for its mobile communication products. Mitchell oversaw the development and marketing of the first pager to use transistors. Motorola had long produced mobile telephones for automobiles, but these large and heavy models consumed too much power to allow their use without the automobile's engine running. Mitchell's team, which included the gifted Dr. Martin Cooper, developed portable cellular telephony, and Mitchell was among the Motorola employees granted a patent for this work in 1973. The first call on the prototype connected, reportedly, to a wrong number. While Motorola was developing a cellular phone, from 1968-1983 Bell Labs worked out a system called Advanced Mobile Phone System, which became the first cellular network standard in the U.S. Motorola and others designed and built the cellular phones for this and other cellular systems. Martin Cooper, a former general manager for the systems division at Motorola, led a team that produced the Dyna TAC-8000X, the first commercially available cellular phone small enough to be easily carried, and made the first phone call from it, and later introduced the so-called bag phone. In 1992 the first smartphone, called IBM Simon, used AMPS. Frank Canova led its design at IBM and it was demonstrated that year at the Comdex Computer Industry Trade Show. A refined version of the product was marketed to consumers in 1994 by Bell South under the name Simon Personal Communicator. The Simon was the first device that can be properly referred to as a smartphone, even though that term was not yet coined. Technology. AMPS is a first-generation cellular technology that uses separate frequencies, or channels, for each conversation. It therefore required considerable bandwidth for a large number of users. In general terms, AMPS was very similar to the older OG improved mobile telephone service, but used considerably more computing power in order to select frequencies, hand off conversations to PSTN lines, and handle billing and call setup. What really separated AMPS from older systems is the back-end call setup functionality. In AMPS, the cell centers could flexibly assign channels to handsets based on signal strength, allowing the same frequency to be reused in various locations without interference. This allowed a larger number of phones to be supported over a geographical area. AMPS pioneers coined the term cellular, because of its use of small hexagonal cells within a system. AMPS suffered from many weaknesses compared to today's digital technologies. As an analog standard, it was susceptible to static and noise, and there was no protection from eavesdropping using a scanner. Cloning. In the 1990s an epidemic of cloning cost the cellular carriers millions of dollars. An eavesdropper with specialized equipment could intercept a handset's ESN and MDN or CTN. The electronic serial number, a 12-digit number sent by the handset to the cellular system for billing purposes, uniquely identified that phone on the network. The system then allowed or disallowed calls and/or features based on its customer file. A person intercepting an ESN-MDN pair could clone the combination onto a different phone and use it in other areas for making calls without paying. Cellular phone cloning became possible with off-the-shelf technology in the 1990s. Would-be cloners required three key items: a radio receiver, such as the Icon PC-1000, that could tune into the reverse channel, a PC with a sound card and a software program called bandpair, a phone that could easily be used for cloning, such as the Oki 900, the radio, when tuned to the proper frequency, would receive the signal transmitted by the cell phone to be cloned, containing the phone's ESN-MDN pair. This signal would feed into the sound card audio input of the PC, and BAMPA would decode the ESN-MDN pair from the signal and display it on the screen. The hacker could then copy that data into the OKI-900 phone and reboot it, after which the phone network could not distinguish the OKI from the original phone whose signal had been received. This gave the cloner, through the OKI phone, the ability to use the mobile phone service of the legitimate subscriber whose phone was cloned, just as if that phone had been physically stolen, except that the subscriber retained his or her phone, unaware that the phone had been cloned at least until that subscriber received his or her next bill. The problem became so large that some carriers required the use of a PIN before making calls. Eventually, the cellular companies initiated a system called RF fingerprinting, whereby it could determine subtle differences in the signal of one phone from another and shut down some cloned phones. Some legitimate customers had problems with this, though if they made certain changes to their own phone, such as replacing the battery and/or antenna. The OKI-900, the ultimate tool of cell phone hackers, could listen into AMP's phone calls right out of the box with no hardware modifications. Standards: AMPS was originally standardized by American National Standards Institute, ANSI, as EIA-IS-3. EIA-IS-3 was superseded by EIA-TIA 553 and TIA Interim Standard. With digital technologies, the cost of wireless service is so low that the problem of cloning has virtually disappeared. Frequency bands: AMP's cellular service operated in the 850 MHz cellular band. For each market area, the United States Federal Communications Commission allowed two licensees known as A and B carriers. Each carrier within a market used a specified block of frequencies consisting of 21 control channels and 395 voice channels. Originally, the B-side license was usually owned by the local phone company, and the A license was given to wireless telephone providers. At the inception of cellular in 1983, the FCC had granted each carrier within a market 333 channel pairs. By the late 1980s, the cellular industry's subscriber base had grown into the millions across America, and it became necessary to add channels for additional capacity. In 1989, the FCC granted carriers an expansion from the previous 666 channels to the final 832. The additional frequencies were from the band held in reserve for future expansion. These frequencies were immediately adjacent to the existing cellular band. These bands had previously been allocated to UHF TV channel 70/83. Each duplex channel was composed of two frequencies. 416 of these were in the 824/849 MHz range for transmissions from mobile stations to the base stations, paired with 416 frequencies in the 869/894 MHz range for transmissions from base stations to the mobile stations. Each cell site used a different subset of these channels than its neighbors to avoid interference. This significantly reduced the number of channels available at each site in real-world systems. Each AMPS channel had a one-way bandwidth of 30 kHz, for a total of 60 kHz for each duplex channel. Laws were passed in the U.S. which prohibited the FCC type acceptance and sale of any receiver which could tune the frequency ranges occupied by analog AMPS cellular services. Though the service is no longer offered, these laws remain in force. Digital AMPS. Later, many AMPS networks were partially converted to D-AMPS, often referred to as TDMA. D-AMPS, commercial deployed since 1993, was a digital, 2G standard used mainly by AT&T Mobility and US Cellular in the United States, Rogers Wireless in Canada, Telcel in Mexico, Telecom Italia Mobile in Brazil, Vimpelcom in Russia, Movilnet in Venezuela, and Cellcom in Israel. In most areas, D-AMPS is no longer offered and has been replaced by more advanced digital wireless networks. Successor technologies, AMPS and D-AMPS have now been phased out in favor of either CDMA 2000 or GSM, which allow for higher capacity data transfers for services such as WAP, multimedia messaging system, and wireless Internet access. There are some phones capable of supporting AMPS, DIMPs and GSM all in one phone. Analog IMPs being replaced by digital. In 2002, the FCC decided to no longer require A and B carriers to support IMP service as of February 18, 2008. All IMPs carriers have converted to a digital standard such as CDMA 2000 or GSM. Digital technologies such as GSM and CDMA 2000 support multiple voice calls on the same channel and offer enhanced features such as two-way text messaging and data services. Unlike in the United States, the Canadian Radio, Television and Telecommunications Commission and Industry Canada have not set any requirement for maintaining IMP service in Canada. Rogers Wireless has dismantled their IMPs network. The networks were shut down May 31, 2007. Bell Mobility and Telus Mobility, who operated IMPs networks in Canada, announced that they would observe the same timetable as outlined by the FCC in the United States, and as a result would not begin to dismantle their IMPs networks until after February 2008. OnStar relied heavily on North American IMPs service for its subscribers because, when the system was developed, AMPS offered the most comprehensive wireless coverage in the U.S. In 2006, AT&T asked the FCC to extend the AMPS deadline due to many of their alarm systems still using analog technology to communicate with the control centers. Cellular companies who own an A or B license were required to provide analog service until February 18, 2008. After that point, however, most cellular companies were eager to shut down AMPS and use the remaining channels for digital services. OnStar transitioned to digital service with the help of data transport technology developed by Ubiquiti, but warned customers who could not be upgraded to digital service that their service would permanently expire on January 1, 2008. Companies that used analog AMPs, Verizon Wireless formerly operating an AMPS network, on February 18, 2008, Verizon has discontinued all AMPS service. Now primarily operates on CDMA 2000 technology. Bell Mobility and Telus Mobility operated AMPS networks in Canada, though they have since been overlaid with digital services. Both Bell Mobility and Telus Mobility had announced that they would observe the same shutdown guidelines as in the United States, and decommissioned their AMPS networks in 2008. Altair in 2005 disclosed that only 15% of their total customer base are still using the existing analog network. The company has posted a three-phase turn-down schedule, which was completed in September 2008. With the acquisition of Western Wireless, Altair now took the claim of the largest network in America. The claim was true, oddly enough because of wide analog coverage in rural areas. All Altair AMPS and DIMP service was discontinued in September 2008. Coastal Offshore Cellular operated an AMPS network in the Gulf of Mexico that stretched from south of Corpus Christi, Texas to south of Gulf Shores, AL. In 2006, Coastal was the only carrier in the U.S. whose entire customer base was still 100% analog-based. In 2007, Coastal was merged with Petrocom and Solar Communications to form Broadpoint Incorporated, and the network was converted to GSM. Moviline was the analog service provider for the Spanish operator. Moviline has operated an ETA CS900 network in Spain. Since December 31, 2003, the system has been closed to new users. At that time, it covered 100% of the Spanish population, but now some antennas have been given to GSM operators. The Moviline brand has been completely replaced by Movistar, the digital brand of Telefacube Nica, since 1992. The network was completely converted to GSM and it's in all Spanish territory. Movistar have a 3G network with Universal Mobile Telecommunications System, UMTS, technology, and offer services over GSM in places without 3G coverage. AT&T Mobility, in areas where AT&T Mobility previously had DIMPs operating on 1900 MHz frequencies, no analog IMPS network existed, and the DIMPs network on the 1900 MHz frequency was shut down in mid-2007. Service on the remaining 850 MHz IMPS markets was discontinued along with 850 MHz DIMP service on February 18, 2008, except in areas where service was provided by Dobson Communications. The Dobson AMPS and TDMA networks were shut down on March 1, 2008. Telecom New Zealand operated an AMPS TDMA network in New Zealand from 1987 until 2007 throughout the whole country, and the network was renowned for its superb coverage. In 2000, Telecom announced that they would discontinue the AMPS network within 5 years to give customers an opportunity to transition to the CDMA 2000 and later 1xATT technologies that replaced it. They later extended that deadline until 6 p.m. March 31, 2007. At approximately 7:15 on March 31, 2007, the AMPS TDMA network ceased to function. Telstra operated an AMPS network in Australia from February 1987 until the end of 2000. As part of the introduction of mobile phone competition in Australia, the Australian government mandated GSM as the new standard for mobile networks, and required that Telstra close the AMPS network by 2000. However, GSM base stations could only serve a limited area. While this was okay for Europe, it meant that GSM could not cover large, sparsely populated rural areas of Australia cost-effectively. Telstra deployed a CDMA network, which did not suffer this limitation, and while the AMPS network was closed down at the end of 1999 in the major cities, the closure deadline was extended until the end of 2000 in rural areas to ease the transition to CDMA. The CDMA network has since been replaced by an 850 MHz UMTS network. NextG, SaskTel, operated an AMPS network in Saskatchewan, Canada. It was the third largest AMPS network, by subscribers, in the world at the time of its turndown. It was officially shut down site by site starting at 0 o'clock on January 2, 2010 after 21 years of service. SaskTel continues to run CDMA and UMTS networks. Etisalat operated a Motorola TAC network in Sri Lanka. It was the largest analog network in Sri Lanka. The site was officially shut down on October 31, 2006 after 17 years of service. Etisalat, Sri Lanka continues to run GSM and HSPA+, evolved high-speed packet access, networks. Pelphone began offering nationwide AMPS service in Israel in 1986. In the mid-1990s it converted to CDMA and in the mid-2000s converted to UMTS. Pact was granted an AMPS license in early 1990 to operate a cellular telephone network throughout Pakistan. It was the first company granted a free license to carry out cellular phone services in Pakistan. It carried out AMPS services until 2004, after which it switched to GSM. See also, History of mobile phones. References, Interview of Joel Engel. Citations